Chapter 6, Exercise number 2. IQ is normally distributed with a mean of 100 and a standard deviation of 15. Suppose one individual is randomly chosen. Let x equal to the IQ of an individual. Here in this part A, they want us to express the random variable and the probability distribution with the notation. And here we have a normally distributed probability distribution. So we have the notation that we'll use is n, and then they usually look for the mean and the standard deviation in the parentheses. So the mean is 100, the standard deviation is 15. In part B, they're looking for the probability that the person has an IQ score that's greater than 120. They want us to include a sketch and the notation. So draw the best bell curve that you can draw. And we know that the mean is 100, so for normally distributed situations, the mean is right in the middle. We want an IQ score that's greater than 120. So we shade in the area from 120 on to infinity. The probability statement that would need to be written would look like this. This is the probability that your random variable is greater than 120. And it would also be good to actually write down the calculator command. So for this, we will call on our calculator command normal CDF. And normal CDF looks for a low number, a high number, and the high number here goes all the way to infinity. So since we can't theoretically put infinity, we will put one of the largest number that the calculator can handle, and that's 1 with 99 zeros, and that's denoted by 1E99. After that, we're looking for the mean and standard deviation. So that's exactly what we're going to put in our calculator, so we just have to look for it. The normal CDF can be found under second and vars, which looks at the distribution. We never use the PDF. We're always going to be using the CDF when we're looking at the normal distribution. So again, the low, comma, the high, this is the 1. The E is right above the comma, so that's the second function of the comma, and then 99, comma, the mean, comma, and a standard deviation. So it looks like the value here will be 0.0912. Part C. Mensa as an organization, whose members have the top 2% of all IQ scores. So they want us, in this case, instead of looking for the probability or the area, they want us to give this a 2% area, and they want to know what this value is that separates the top 2% from the rest of them. So in this case, we want the probability that a random variable is bigger than some number, so that we have the top 2%. Now, for this, we will call on our inverse norm function in our calculator. And what the inverse norm asks for is the area to the left. And notice our shaded region here is the area to the right. Our shaded region is 2%. So we just have to take the complement of that, which is 98%. And so the area to the left is 98. So that's what we're going to put into our calculator. And after you find the area to the left, you simply put the mean and the standard deviation. And whatever this is going to be the number that we're looking for. So let's go to our calculator, second function, and vars again. And the third option is the inverse norm, 0.98. And then the mean and the standard deviation. So it looks like we're looking at 130.806, and I think 130.8 would be good. That's part D. Oh, that's part C. Part D, the middle 50% of the IQ scores fall between what two values? So what we're looking for in this scenario is around 100. We're looking at 50% of the IQs. So we're looking at two values that capture 50% of the middle. So what we can note here is that we have some information. If we're looking at 50% in the middle, we're looking at some information here that this is 25% on top and 25% on the bottom. So it looks like we're going to be using an inverse norm again, and the notation that we'll need to use here is the area to the right, and then the probability that we have some values between our random variables, or our random variable is between a couple of values, and we just need to find those couple of values. So the first one is fairly easy. It looks like we're going to be calling on the inverse norm again, and the area to the left is 25%. And for our second one, similarly, inverse norm, but the area to the left is no longer 25%, rather it's the complement, or 75%. And so we want these two values from our calculator. There are a couple of tricks from the calculator, or one in particular. We want to call our last input or entry. So we hit the second function and entry, and then it's going to be the inverse norm, the same command as last time, except instead of 98%, we're going to call on 25%. So it looks like for this very first one, we have an 89.88. So we'll call that an 89.9. For our lower limit and our upper limit, the same command again, second function and enter. And then I'm just going to change the 2 to a 7 to make a 75% area on the left. Then enter. It looks like we got 110.117. Let's call that 110.1. So these are the two values that we found, and these are the two values that would capture the middle 50% of the population. Okay, that's it. Good luck on your homework.